Hello, we're back. This is review number 9 in the spring of 2019, so make sure you're watching the right review. The first section, this is a repeated section from the last test, and because of that, and many of you did do very well on it, I want to give you the opportunity for some extra credit. So at the end of this section on the test, you'll see a bonus question, completely optional, a little more challenging than the typical questions, and if you want to attempt it and you get it right, I'll give you some extra credit on your score. So remember, these are the questions where you need to get and keep a common denominator, and some of us had some trouble with that issue, where I think we started confusing 8.5 and 8.6 together. So refer back to a worksheet we just did last week, where I compared 8.5 to 8.6 side by side, and you'll really understand what I'm talking about if you look at that worksheet. So there's no factoring to happen on the denominators, and I noticed that my denominators happen to be the same denominator, so we already have the common denominator of 5x minus 1. I like to put factors in parentheses, so you'll see that a lot. And then we're supposed to simplify this numerator. Now this one's a little tricky because you are subtracting, and you are not just subtracting the 8x, but you're also going to subtract the, the 9 right there. So what I'm going to write down is 19x, and then a minus 8x, and then a minus 9. So watch for that distribution there. Of course, we're going to collect our like terms, and our final simplified numerator would be an 11x minus 9. There's no further factoring on that question. Sometimes at the last minute the numerator will factor, and then something cancels, but since these are clearly not the same terms, nothing's going to cancel. That is our answer. I'm going to let the b's, I'm going to leave them alone so you can try them on your own. Oh, that rhymed. Alright, this next question, you have a denominator of x, which happens to be a very, very different question. Different denominator than x minus 7. So my common denominator is not just an x, but also an x minus 7. We always leave them in factored form. When I look at my numerators, I need to do some building here, right? So this denominator doesn't match the common denominator yet. He is missing the x minus 7. And then this numerator over here, sorry, this denominator is missing the x, so we're going to multiply the numerator and denominator by that. And then you're going to have some, of course, simplification up here in the numerator. So if I were to distribute the 5 times x minus 7, that would be 5x minus 35. And then plus 4x is the other part. Keep on simplifying. You get a 9x minus 35, which doesn't factor any further. So that means we're done. So no factoring, nothing's canceling. We are totally done with that question. Now the next one is the one where I think some of you had a little concept miss that you weren't expecting to get wrong. Looks so unassuming, right? I'm looking at this question going, oh, it already has common denominators. How wonderful. Must be so easy. So your common denominator is that x minus 5. Keep it. And then we look at our numerators and we're like, well, that's great. There's nothing to do. 9x squared minus 45x. But then remember, there's always one last minute thing you got to look for, and that would be, is there any further factoring here at the last minute? So that numerator does factor. You have a common term of 9x that you could take out of that. And if you were to factor out a 9x from this green thing, you would have 9x times x minus 5. And it's still being divided by the common denominator of x minus 5. And this is a case where there is last minute cancellation because of the factorization. So this simplifies down to just a 9x. You can say 9x over 1, but 9x works as well. So there's one more question I think coming up here. Yep, and it's a subtraction problem. We most definitely do not have any common denominators right now. The good news is there's no factoring right off the bat. 3x minus 1 is a factor on its own, and x plus 2 is a factor, and neither one of them factor further. So my common denominator, the thing I'm going to need, I'm going to write it down here so I have more room. I'm going to need a 3x minus 1 and an x plus 2. So this fraction over here, this is missing the x plus 2. So we're going to multiply both numerator and denominator by it. This fraction over here is missing the 3x minus 1. Okay. Whoops, it's minus 1. Now we have quite a bit of simplification that's going to happen here in the numerator, and I'm a little nervous, so maybe I won't do anything in my head, or at least not very much. So I'm going to multiply 5 times x plus 2. And then I'm also going to take the negative x, and we're going to distribute that to the, I don't know why I'm switching colors so weird, times the 3x minus 1. Get my colors under control. Here we go. Goodness. Now we're going to distribute 5 into his parenthesis set, and careful, this is a negative 8, negative x into that parenthesis set. So our numerator becomes 5x plus 10, and then we have a minus 3x squared, and then a plus x. Now don't forget, you're keeping that common denominator. It's not going anywhere. And as I look through that numerator, I see I have a couple of like terms. So I'm going to rewrite that numerator in standard form at least. My goodness, I hope that doesn't factor any further. There's always a chance that the numerator factors further. You could definitely take out a negative, but then 3, 5, 2... Let's see, that's not going to work. I'm kind of thinking ahead, and I don't think anything's going to cancel if I even could factor this. So I'm just going to leave this problem. And I will give you a little bit of a heads up, guys. On your test, you are going to see a question. Every question that we just saw in the review will show up on the test. Also, you're going to see an error analysis question. So that means you're going to see somebody else's work and that child has messed up. They always mess up, and your job is to fix their work, like play teacher, and then describe for me what their like concept mistake was. So you can give them some feedback. You get to play Mrs. Abruzzo. How's that? All right, this section, this is the solving. So this is the one where we are eventually going to be solving the rational equations, but the first task I have for you is that I need you to determine for me what are the excluded values. So these are the things where you say like x can't be, and then whatever the answers are. So you look at your denominators, and we remember that my denominator cannot come out to 0. So if you're struggling with this skill, what you're going to do is you're going to say x plus 7 cannot be 0, like literally solve it or set it up. And then x squared minus 49 cannot be 0. Now this one's easy to solve. You just add the 7 over, so x can't be 7. If you were to solve this one, though, and you'd add the 49 over, you'd then square root it. So you'd get like x squared cannot be 49. And then when you square root both of these, remember, it's both positive and negative 7. Both of those numbers would be excluded from our solution set. All right, now we are finally going to solve. So I've given you a couple of examples of the same styles you're going to see on your test. This is the stuff where you're going to solve an equation, so you're going to get x equals at the end of your problem, and then you're going to use an LCM to knock out the denominators. So I'll write that down. And I think for some of you, rather than trying the shortcut, that's causing a lot of problems for some of you as far as accuracy goes, and these are so easy to mess up, so let's not use the shortcut. 2x, I see another 2x, and then I see an x plus 1. So my LCM that we're going to use is both of those things, a 2x and an x plus 1. So I'm going to distribute this in front of every single term. And it's going to look pretty elaborate at first, so I'm going to use lots of colors. And then, after we do some simplifying, we'll see it's really not that bad. So next term is 6, which this guy, oops, I was using black there, wasn't I? This term right here, the 6 over 2x, does simplify right off the bat, but I don't think it was worth it to simplify because we would have had to keep the 2 over here anyways, so whatever. If you did, you did. If you didn't, you didn't. It's okay. Plus, keep going, Abruzzo. And then the LCM again, 2x times x plus 1. I know it's a pain to have to write this out every single time you distribute it. But for some of you, the mistakes I'm seeing, I think it'd be worth it. Because this problem is not exactly a fun time anyways, so you might as well just get it right, even if it takes you an extra minute to write it all out. I will tell you that children who write them out and do exactly as I'm doing here, those are the children who get them right, consistently. Alright, so every bubble here, we should see some major simplification, because after this step, there should be no more denominators. And if you still have a denominator, then we have a problem. So here the 2x will cancel, over here the 2x will cancel again, and over here the x plus 1s will cancel. So yay, we got rid of all of our denominators. Now let's see what we have. So you have a 7 times x plus 1. So if you don't mind, well, I guess I can go a little slower. I'm not in a hurry. I was going to say I was going to skip that step, but maybe not. And then we have a 6 times x plus 1. And then over here, we have a 3 times a 2x. So now after I distribute, we're going to have an equation that, yes, we're going to have to clean it up again. So 7x plus 7 equals 6x plus 6. And then 3 times 2x is 6x. So collecting all your like terms to one side, it's going to take me a minute. Hold on, that's a 12x plus 6. All right, now let's start moving terms around. I'm going to move the x's to the right, which means I'm going to move my constants to the left. Oh, I forgot my very important step at the beginning. Gosh, I'm so bad at that. I was supposed to tell you what x cannot be. I think we're going to be okay. Because right here, we're going to divide both sides by 5. We're going to get a fraction of 1/5. Which is definitely not one of those excluded values that I was supposed to warn you about. So up here, we can't have x equals 0. That would have been a problem. And then we can't have x equals -1. That would have been a problem. So a little side note, we can't have either one of those. Good news, we didn't have either one of those, so we get to keep our answer. Remember, if your answers cross off, they are extraneous. And if those are the only answers that you had and you end up crossing them off, it's not the end of the world. It just means that you have no solution. All right, now this one, be careful because these two denominators, while they do match, they are factorable, and you want to factor them so you can see the individual factor pieces. So there's a common x that you're going to take out of each of those. And factoring is always the right step, because even though I know you guys don't think of it this way, it does make your work easier. Oh, I'm going to forget it again, real quick. X cannot be 0, and x cannot be -1. Again, I don't know why that showed up again in this question, but it did. All right, so your LCM, you know what, I need to move that over. X cannot be 0, and x cannot be -1. All right, your LCM, I need to knock out an x and an x plus 1. All right, so if you insist on taking the shortcut, this would be a good problem to take the shortcut on because there's very little that doesn't cancel. So what I mean by that is when you multiply this LCM to the first fraction, the x plus 1s will cancel, but you still have a 3 times x. So the shortcut means you're just writing down things that aren't going to cancel. In this next fraction, the x and the x plus 1s would cancel because the LCM matches the denominator. So you're just going to have a 1. I don't know why that went red. Let's try again. 1. And that same thing is going to happen here in this last fraction. The x and the x plus 1 are going to cancel because the denominator matches the LCM. So you're just going to have an equals 4. So that was a really nice question if you understood how to take the shortcut. But if you're thinking to yourself, oh man, I am not taking shortcuts on my test, that's where I mess up. I do not blame you. I got a little excited when I saw this question because I thought we were going to get an extraneous solution. But turns out we get x equals 1, which is not -1. So I think we're okay. You're going to have some factoring here on 8b. I want you to try that one on your own. I know some of you dread factoring, but remember these problems kind of give you a leg up on factoring. If you look through the whole question, usually the factors that you need, at least some of them exist somewhere else in the problem. So keep that in mind. Here we have essentially a proportion, which if you want to go back to cross multiplication style, which you guys refer to as the butterfly method, which makes me cry, go ahead. But what you're really doing is you're multiplying by 5x minus 4 and 2x plus 3. Real quickly, before I do any work, I should make a little note that x can't be, let's see, if I set this one equal to 0 or this one, you know, you'd get 4/5. And x can't be, let's see, -3/2. So if we don't get either one of those answers, we're going to keep our answer. So distributing this LCM into the first fraction, the 5x minus 4 is going to cancel, so you still have a 1 times the 2x plus 3. and then equal sign, and then the next fraction, this time the 2x plus 3 will cancel. So you still have a 2, my pen is going crazy, alright, you still have a 2 times the 5x minus 4. And some of you are like, but that's exactly what I got when I used, quote, butterfly method. Now, we normally distribute the 1. I'm not even going to refer to your butterfly method anymore, you know I hate it. Distributing a 1 is stupid, Averzo, it's just 2x plus 3. But you do need to distribute the 2. Okay, pen, come on. 10x minus 8. Alright, let's solve. I'm going to move the x's to the right again. So that means I'm going to move my constant to the left. I think we're okay with extraneous solutions here. I don't think we have it. We have a weird fraction, but not one of the weird fractions that we couldn't have. So x equals 11 over 8 is what I'm getting. Let's double check my key, make sure that's what I got. Yeah, alright. So if you want to think of it as a cross multiplication problem on that particular one, you sure can, because it was a fraction equals a fraction. But you can't do that on the other questions when there's addition or subtraction signs and there's more than one term. Alright, everybody's favorite, the chart problems. I would like you to fill out the chart on your test. However, I did give you a chart like I did on the review here. So remember that the rate is the rate that it takes them to do the job alone, but the time is the time it takes them to do the job together. So Betty can finish homework in 3 hours, so one job in 3 hours. Jackie can do the same amount of homework in 2 hours. How long would it take them if they work together? Well, that'd be cheating, so you shouldn't do that. But let's call it x. Alright, so we're going to multiply these together. And that's going to tell us a fraction that represents how much of a part each person did. So 1/3 times x is x over 3. And then 1/2 times x is x over 2. And the way this problem works is you add them together. And it equals one job. So that's what we set up. We say x over 3 plus x over 2 equals one job. And then it doesn't have to be the least common multiple, but you just need a common multiple that'll knock out a 3 and a 2. So most people go with a 6, which you are going to distribute to every single term in the equation. So that's going to reduce to, let's see, 6 divided by 3 is 2x, 6 divided by 2 is 3x. And then please don't forget, this is not a 1 anymore, it's 6. So solving for x, these usually come out to decimal answers. This one does as well, it's 1.2 hours. So if they cheat and work on their homework together, it'll only take them a little over an hour. Alright, so I'll leave 10b for you guys to do, but if you look at 11a, this is the other type of chart problem you're going to see where I tell you how long it takes one of the people to work if they are doing the job by themselves, and then we tell you how long it takes when they work together, and your job is to find out how long it takes that second person if they were to work alone. So for Joy, she finishes the exam in 4 hours, so her rate is 1 over 4. But they don't tell me Sale, and in fact that's the question, so we're going to call Sale 1 over x. So that very Chicagoan, sorry, Sale. Alright, how long does it take them to work together? Well, right here, 1.71. I think I'm doing that in green. Alright, so the process for setting up the equation is the same. You're still going to multiply each person's rate by the together working time. This time, though, it's not a variable. So for Joy, it's 1.71 over 4. Leave it like that. And then for Sale, it's 1.71 over x. The equation is exactly the same setup. You're going to add these together, and it equals one job, because when they work together, they will finish one job. And this is more of an Algebra 2 style rational equation. So this time, I'm looking to knock out our denominators. We have a 4 and an x, so an obvious common multiple would be a 4x. So distributing that into every term, you're going to have some cancellation, and okay, pen. So like right here, 4's will cancel, so you're just going to get a 1.71x. And then over here, the x's will cancel, So it's 4 times 1.71, which we'll come up with in a minute. And then 4x times 1 is 4x. So multiplying those together, I think I wrote that down. I think it's 6.84. And then got a little two-step equation to solve. Pen. Come back. Alright, 1.71 being subtracted to the other side. Alright, so we have 6.84 equals, what does that say, 2.29? One more step and you're home free. And this comes out really, really close to 3. It's like 2.99, or you can just go ahead and round that up to 3 hours. Okay, so then there's one more section on your test, and that is the right triangle trig review. Now I know it's review because it's like your third time learning it, but I still want you guys to study and practice, and especially remember how to type these on your calculator and practice typing them on your calculator. That's usually the most common error. The ratios for sine, cosine, and tangent must be memorized. So remember, sine ratio is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And tangent is the opposite leg over the adjacent leg. So who's opposite and adjacent to you depends on where your angle is located. So if we're discussing this triangle and referencing it from this angle over here, that means that is literally your reference point. So you pretend like you're standing right there. The hypotenuse is always going to be the longest leg of a right triangle, which is directly across from a 90-degree angle. So I'm going to come back and color code my formula here. And then opposite of you would be your opposite leg. So directly across from you, not anywhere near you. Just going to abbreviate that one. And then adjacent means next to you, but not the hypotenuse. That's a J. Okay. I don't know what's happening to my writing. Alright, so because you're going to have application questions, another task that I'm going to make you complete is actually drawing the picture properly and labeling it. So you're going to have a tree. Here you go. This is about as clever as my drawings get. Tree. Hey, that was pretty good. And then you have a shadow, which is 8.4 meters. Now, remember guys, shadows are on the ground. You'd be surprised where some kids put shadows. So shadow on the ground. And then it says the angle of elevation is 17 degrees. So the angle of elevation can be found two places in your triangle. It's actually the same thing as the angle of depression. The angle of elevation is from the ground looking up at something. So this guy right here is 17 degrees. That's the angle of elevation. The angle of depression is also 17 degrees, but it's out of the triangle. It's right here. So because of alternate interior angles, anytime they say angle of depression or angle of elevation, I want you to just automatically put that angle down in this bottom part of the triangle, because typically these application questions set up like this. They want to know the height of the tree, so I'm going to call that x. And now I have to kind of set back and look at what's going on in this question. So this angle of elevation is your reference point. That's you. So where you are at, this is the leg that is next to you, the adjacent leg, and this is the opposite leg. So with opposite and adjacent, if I think about my three trig functions that we were looking at, that's a OA, so it's tangent. Remember, SOHCA, TOA is another way for you to remember it. So we're going to set up the tangent of your angle, which is 17, equals the opposite leg over the adjacent leg. And then we're going to cross multiply and divide because these are always proportions. This one happens to be a very easy one-step proportion because you're not going to have to divide by anything because, well, it's 1 times x. So x equals, you would have to type the tangent of 17, close your tangent function, times 8.4. And the other thing you have to remember is that your calculator has to be In degree mode, I will more than likely make a huge announcement at the beginning of your test to switch to degree mode. But if you get a funky answer, it's probably because your mode is in radian. So typing that in your calculator, you should get 2.57. I think it's measured in meters here. And it doesn't really say where to round. Tenths place is probably fine, so if you wrote 2.6, that's fine. Alright, please practice typing those on your calculator, setting them up, all of that. Alright, this time we have a hot air balloon. Uh-oh. Yep, that's hot air balloon, right? Okay. Okay, so my hot air balloon kind of looks like a light bulb. This is why I don't draw. Okay. Basket. Oh, that doesn't look better. Okay, whatever. Pretend. Anyways, it's at an altitude of 675 feet. Altitude is a very fancy word for height. So anytime they say altitude, just remember that it means height. And then they spy a landing spot way over here. And then it says the angle of depression of 25 degrees. So remember, angle of depression is the one that's outside of the triangle looking down towards the ground. So because the angle of depression is 25, that means also your angle of elevation is 25 degrees. So this guy down here, also 25 degrees. And because this is the one that's actually in the triangle, this is the one where you pretend you're standing at. Okay, that's you. You're not the balloonist today. You're that dude on the ground. Okay. So for that triangle, they want to know the horizontal distance from the landing spot to where the balloon is currently located. So they want to know this. So once again, we have an opposite leg from this reference point here, this angle, and we have an adjacent leg. So we have TOA again. So we're going to be setting up tangent of 25 equals 675 over x. Now this one is not as simple as one step on your calculator. When you cross multiply, you're going to get x times the tangent of 25 and then equals 675. And then to solve for x, we're going to have to divide this tangent of 25 over to the other side. Again, check in your mode. Once you change it, you should be good, but if you've never typed anything today, you're going to need to look at that. Y'all should get 1447.5 feet. Now, I'd never have ridden in a hot air balloon, guys, but if I did this work and I found out the answer was something stupid like 12 feet, like, that doesn't make any sense. Or if I got an answer of negative 32 feet, you know, I might realize something's wrong with my calculator. So the good news is, even though some of these problems are a little lame, you guys could anticipate whether your answer makes any sense or not. Alright, I got one more question here. We have a supporting cable to the top of a tower. Okay, I'm not drawing a tower, so pretend that's your tower. And the tower is 250 feet, so that's the height. 5, gosh, can't write. Okay, I'm going to try that one more time. 250. And the tower is 250 feet, but then it says the cable is 300 feet long. So the cable connects the top of the tower down to the ground. And they want to, oops, they want to know what angle does the cable make with the ground? So they want to know this angle down here. You can call this x, or I like to use the Greek letter theta, because that's something you're going to see in your future. So this time, you have a hypotenuse clue. This is your reference point, right? And you have an opposite clue. So OH is so, which is sine. So you're going to set up the sine of your angle. This time I don't know the angle, so whatever you called it, some variable, equals 250 over 300. And in order to solve for the theta, you have to undo a sine function. So you would have to apply an inverse sine. Of course, we're going to do it to both sides of our equation, but this is the one that you're going to type in your calculator. And when you type that in your calculator, You get the angle it makes with the ground. It's about 56.4 degrees. All right, good luck on your test.